Good evening and welcome back to another lecture for cloud computing. In the last class, we had started our discussion about the Elastic Compute Cloud, which is the infrastructure as a service for the AWS platform. And we discussed about the dashboard that is essentially used in order to create the services and stuff like that. We talked about the different instance types that is provided by AWS platforms. We discussed the Amazon Machine Image Catalog, which is basically the marketplace for getting a hold of all of the different AMIs that is either provided by AWS itself or any kind of trusted third party or any other users who can develop their own machine image and they can submit that to the AMI catalog itself. So if there is anything that is specific that you're looking for, you can always check that out and kind of use the AMIs from those marketplace itself. We discussed about what are the different components that kind of plays into action when you are working with the EC2, right? In the terms of the elastic IPs, the public IPs, the private IPs, how you can have load balances, how you will have different types of storage volumes that will be available to you that you can use, how you need a key pair in order to perform authentication, in order to connect to your EC2 instances once you launch them through AWS. And then most importantly, security groups, which basically is a type of firewall policy that is integrated on the EC2 instance level itself that kind of monitors the traffic that is going to come into your EC2 instances, or generally speaking, any kind of services that is associated to those security groups. And then you can decide what are going to be the inbound traffic rules and what are going to be the outbound traffic rules for those security groups. And essentially, we had developed our own security groups as well. When it came to demoing some of the exercise, we created the demo SG Ohio for us, and we added some inbound traffic policies with respect to remote desktop protocol, HTTP, and later on we added HTTPS, and then SSH for basically kind of using the terminal in order to log into the EC2 instances that we had created, right? So we learned about the creation of those EC2 instances. That is pretty straightforward once you get an understanding of it. Added some volumes to it by default, at least the options that are available to us on the free tier account. And we discussed about how you can basically set up a static website using your EC2 instances, okay, with the help of making sure that you have the correct inbound traffic rules in your security groups and stuff like that. So at this point of time, if you redo the exercises, for those of you who are new to this, you basically have an understanding of how to kind of launch a VM on AWS platform and maybe kind of transform that VM to act as a web server to host your static websites, right? So at certain point of time, if you're ever wondering like, okay, I'm using AWS, how can I make practical use of it? Then this is one of the use case application scenarios, and not just using it as a VM computer. You can even host your static websites, right? But there is an emphasis here on the keyword that it is static in nature. That is, you can have a website and not a web application, because of course you have to run a backend in order to make it a dynamic web application in itself. And there are different other services which kind of facilitates that process. It's not that you cannot do it in EC2, you can treat it as any other local computer. So just like you can run a backend on your local machine, and when you are testing and debugging that in the developer mode, you essentially use the localhost URL in order to kind of test whether your backend is running and operational and things like that, right? You can choose to transform your EC2 into a dynamic web server, and you can run your server there as well. And that can be transformed into kind of supporting or hosting a dynamic web applications as well. The reason why I'm saying that it's not the first choice is because there are other services on EC2 itself, the Elastic Beanstalk and stuff like that, that allows you to kind of choose the different backend technologies depending on which one you will be using to develop your full stack web application, and then kind of set up the environment and then develop within that environment that full stack application that you're trying to design, right? So later on down the course, when we get to that point, we will see those setting up those environment as well. So what I want to kind of go over today is basically two major things, right? The first one is to understand a little bit about what we had discussed previously when we were talking about the IAM service, was basically when we talked about IAM, which is the Identity and Access Management Service for AWS, right? And it is one of the most crucial services, and that is where you should start off with whenever you're developing your own ecosystem. And that is where, using that service, you kind of handle all of the authentication, access control for different users, creation of user accounts and stuff like that for your organization. So it's a pretty important service, right? And when we were looking into IAM at the very beginning, right, after creating our custom billing alarm and stuff like that, we mostly discussed about creating user groups, okay? And we attached permissions and policies that is associated to that particular user group, right? And then we also kind of went into the users category where we added the users, and then we associated those users to those user groups that we had created. So in that way, as an administrator, we don't have to worry about thinking like, okay, do the independent users have any kind of access control policies associated with them, depending on the roles or the type of job that they are going to be doing in my organization, right? So in order to kind of relieve ourselves from that headache, the better step is to first create the groups of different users that you will have within your company or within your organization, associate the policy to those groups, and then add users and then associate the users to the user groups, right? So that way you don't have to do a 1:1 monitoring. It's always a monitoring of making sure that, okay, your groups have permissions and policies, and then you associate users to those groups, right? But in addition to these two categories, there is also another category that is there that we have to talk about a little bit, is known as IAM roles, right? What this does is that it allows different AWS services that is going to be present within your ecosystem, within your cloud ecosystem, to kind of assume certain roles that generally users will be doing with respect to accessing other services. So what I mean by that is that imagine that you create a user group which is in the form of an administrator, right? Or if you create a user group which is in the form of a database developer and something like that, right? Or you create a user group which is in the form of a backend developer and things like this, right? So just to throw you a few examples to get an understanding of where we're going with this, right? So if you develop these groups, right, and then if you develop or if you create different user accounts and add them or associate them to these existing groups, right, then these users will be able to enact or access all of the different services that is permitted by the policies that is associated with the groups that you have created, right? So that means if you are an admin, you have access to all of the different services that will be present within this ecosystem, right? If you have a database developer role or group, if you belong as a user to that group, then you will be able to basically perform read and write operations to the database services that may be present or created within this particular AWS platform, right? But think about it this way, that instead of a human that is a user, what if another existing AWS service within your ecosystem is trying to access another service that is also present? So for example, let's say you have an EC2 instance, right? And you have a backend server that is running on it. And then on top of that, you have some sort of relational database service, which is typically AWS RDS, right? And then the EC2 instance needs to communicate with that database service in order to read and write the data from it, right? In addition to that, you can think of another scenario where, let's say, an EC2 instance is basically acting as your backend server, similar to that, but it is trying to store some kind of media information or some kind of storage information, let's say, which you have captured and saved inside the simple storage service, which the acronym is known as S3, right? Which is the object-based data store for AWS itself, right? So now, if you are a user in the admin group, then you can create for the admin group the read and write access policies for, let's say, either the S3 storage or the RDS, right? As an example, right? But essentially, EC2 does not have access to those different services, right? So I hope you understand where we are going with this, is that in order to allow existing AWS services that you have within your cloud platform on Amazon to be able to communicate with other existing services, you need to give them, that is these services, the permissions based on the policies which will allow them to do the roles that you want them to do. In this particular case, the role that you want EC2 to kind of dispense is to be able to basically read the data from a database, or read the data or write the data from a data store, right? So that is the whole idea. So you wanted to assume the role of a user, so to speak, in a manner of speaking. So we need to be able to create these roles and then associate those roles to the EC2 or any other services that is trying to perform some similar operations. Because in the absence of creating these roles, the only other mechanism that you have in place for these different services to be able to communicate is that we have to use the key value pair. Remember, we created these key pairs that allows us to kind of communicate or authenticate that that user who is trying to access that particular service is basically allowed to be able to communicate with that, right? So, okay. So instead of doing that, this key pair, instead of creating that key pair, and it's a little bit risky, completely relying on key pair or access keys or API keys. The reason behind it is because whenever you want to rely on that method of accessing a certain service, that is, oh, you can generate an API key for RDS, an authentication URL, and then maybe you include that within your program that is running within the EC2, which is acting as a host for your web server, and then kind of communicate with RDS through that programmatic interface, right? The only downside of that, there is no, like, nobody says that that is not something that you shouldn't do, right? But there is a downside to it, and the downside being the fact that you have to generate a key pair, right? Or an API key, and that API key has to be stored somewhere that will be able to basically access, or that will allow you to implement something that will be able to access the services that we're talking about, right? And that is a security risk to a certain degree, because your keys are only secure as the devices or the programs in which you have stored them, right? So that means right now we all know that we have downloaded a key pair, the private key, and we have saved it on our local machine. So at any point of time, if my local computer gets compromised for whatever reason, right? If the security of my local computer, and that is not the responsibility of the cloud platform, right? That is my share of responsibility. So if I don't know that there are vulnerabilities present in my local system or whatever machine that I'm using to communicate with my EC2, then that will kind of, compromise the private key. And as a result of that, unintended authorization might take place, right? So that is something that we might want to avoid. And the way to avoid it, and whenever we get a chance, is to create what we call as IAM roles, right? And then we associate those roles to services, so that those services can essentially, using the permissions that are associated with these roles. So you do the same thing as you do with user groups. That is, when you create a role, you basically attach permissions to those roles. So for example, I can attach a role permission with respect to, let's say, read S3 bucket, which is the storage service for AWS. So I can create a role and I can attach a permission to that role. And what I can then do is I can take an existing service, right, and associate that service to that role, such that that service, so in this example, that is EC2, can assume the role and then use that to dispense the service that we want it to dispense, which is to basically communicate with, let's say, either a database or let's say either a storage service, and so on and so forth, right? So the first demo that we are going to be doing is with respect to creating this small exercise, which allows us to go through all of the different steps and the processes that is kind of relevant with respect to understanding IAM rules and how they work, right? So for this, the instructions are again on the slide, and the slide is available in Moodle. It's basically titled lecture7.ppt. So for those who want to download it right away, you can go ahead and download it. In addition to the slides, I have also uploaded 2 different data files that you will be needing in order to do the self exercise for today's class, and some of the other exercises that we will be talking about as well. So these are basically uploaded to the mod 3 section, the module 3 section. At the very end, you will find that there is a file called names, and then there is a file called index.html. It doesn't show the extension here, but this one is a CSV file. We will later on need this if you want to kind of do this demo exercise that I have created, which will be a self exercise. You will need this file, right? And then you will also need these 2 files, right? So this is an HTML file and this is a CSV file. And I will kind of elaborate on what is the purpose of these 2 files later on when we get to the Elastic Load Balancer section, right? So, and then lecture 7 is here and you can access lecture 7 from there, right? So what we need, and following the instructions that is already being captured on the tutorial itself. So I will kind of get this down. So the overall goal of what we are trying to achieve here is that given that this is our VPC, there are certain services which are publicly available over the internet, right? One of such services is S3, okay? And S3 is basically an object-based storage system. So you can think, you shouldn't think of it, but if you want to draw analogies, you can think of it like, oh, this is some kind of like an external hard disk that you have for your local system where you just plug it in, you store any kind of data that you generate, and then you plug it out, right? So you can think of it that way, but it has large capacities of holding many different data types, right? So it is not restricted like a database as such, so to speak, right? So it's just for storage purposes. And it is available over the internet, right? So it is not hosted within our VPC architecture. It is not present or associated to a particular subnet, similar to how an EC2 is, right? Or our EBS volume is, which is Elastic Block Store Volume, or the file storage volume that we have that we'll talk about after this EC2 chapter. So it is available over the internet. So the exercise that we're trying to achieve here is that, let's say we create an EC2 instance in one of our public subnets, and we want that EC2 instance to be able to ping the S3 bucket that we will create, right? So there are 3 major steps that will be involved in this particular exercise to understand IAM roles better, which is an alternative to key access, right? We don't have to generate any keys in doing so, okay? The only time we will need a key is basically when we want to kind of terminal into the EC2 instance that we have, right? Otherwise, we won't be able to, show the operations, stuff like that. So the 3 major steps that will be involved in this particular exercise is, of course, first and foremost, we have to create an S3 bucket, right? Without an S3 bucket, we cannot really work with this particular exercise. That is the crux of this exercise. The second exercise is, of course, to create the IAM roles. And the third step is to basically launch an EC2 instance, terminal into it, right? Using SSH, okay? And then kind of go from there and use the EC2 to kind of access the S3 bucket, okay? So we will follow the steps that I have already outlined here in the slides, and we will follow them step by step in order to achieve that. So the first step that we are going to carry out in this exercise is to create a dummy S3 bucket and maybe upload some random dummy data just so that we can view it, right? So just to upload the random data, you can upload either the index file or the CSV file that is available. It is not necessary for you to upload these 2 files only. All you need to do is just upload something, right? It could be basically a text file which says hello world. That is all you need, right? But we need some sort of file to be present there, okay? So let us go ahead and follow through these steps and create an S3 bucket for ourselves. So this is also a little bit of a insight into S3, which we will discuss in a little bit more in-depth detail later on when we actually talk about storage and databases on the AWS platform. So I'm at my dashboard right now, and I'm logged in using my IAM user account, and I'm present in the Ohio region, okay? So the first thing that I'm going to search for in the search bar is the service for S3 itself. So that is basically the scalable storage of the cloud, okay? The simple storage service. So we are going to go into S3. And then here from the top right corner, we are just going to hit create bucket, okay? And then follow the prompts that is kind of given to us. There are some which are self-explanatory, and some require some understanding. But the first and foremost is to give it a bucket name. So we can give it a very simple bucket name. What I'm going to give is the name that I've already come up with, and you can give it your own name, whatever you want. You don't have to follow my naming convention itself. So I'm just going to say, Sen-se test data. Make sure that you are in the correct region, because this bucket is available region-wide, and it's not specific to any VPC or any kind of subnet, where subnets are associated to availability zones. So I want it to be in the same region as that of where my EC2 instance is going to be, because this is not about latency. This is not about performance. This is just about understanding how IAM roles work. So I'm not going to worry too much about it. Okay. So other than that, we have the object ownership. So here the access control list is disabled. Okay. So when you have the access control list is disabled, then you can only perform the operations based on the policies that are associated with this particular bucket, right? So if you are going to enable it, then things will become a lot more stricter, because of course you are kind of listing the fact that you have an access control list that is associated with it, right? The other thing that you have to keep in mind is that there is a default security parameter for all your S3 buckets, is that it blocks all public access. Okay, so any kind of, so since S3 is pingable through the public internet, this is the policy that kind of protects you against any kind of unauthorized or undesired access through your S3 bucket. So that means that if you uncheck this, then anybody who has the URL of your bucket will be able to ping your bucket. It's like, think of it in terms of Google Drive, right? So if you make any kind of folder public, as long as anybody has the URL, they can see the contents of your folder, right? If you keep the sharing off in your Google Drive folders, then nobody can access it, essentially. So this essentially what it is doing is that other than you, nobody can access this, right? So we are going to do just the opposite of what we just talked about, and we are going to uncheck this box. Okay, so unchecking this box will give us further options as to like how we would like to minimize the unauthorized access and stuff like that. But we can just ignore all of this for the time being, because we're not concerned too much about access control for S3 buckets right now. We just want to set up a dummy bucket so that we can show the utility of how IAM roles actually work, right? And if we miss or overlook something, we can always come back and change those things later on. Okay. There is also an option for bucket versioning, that is if you want to keep a track of the changes that is happening. You can enable it, or you can keep it disabled. Well, right now we don't need any kind of versioning systems to be present. You can add tags to it if you want to do it. You can just, ignore it or put it, whatever you want to do. Right now, I don't care too much about putting tags and stuff like that. If you want to do encryption, you can just keep the encryption. You can choose what kind of encryption service you're using, either using key management service or the keys which are basically inherently owned by S3 itself. What do you want to do? So I don't want any kind of services as such. So I can just disable everything, or you can leave it default, whatever it is that you want to do. We are not much concerned about any of these additional settings, right? So we can just ignore the rest of the stuff, leave it in default. So all we care about right now is to make sure that we have public access and give it a name, make sure that the region that we want it to be created in is the one that you have selected, right? So after this, just hit create bucket. And then here it wants us to acknowledge the fact that we are intentionally ignoring AWS's, prompt, the fact that we are making it publicly available. So just check that box that you acknowledge and you understand the risks that is associated with it. And then you can just create it, right? And you can see here with respect to access control, it is telling us that all of the different objects can be public, right? So once you go into that bucket, right, essentially what you do is just left click on this particular name here. That will take you within the bucket. And at this point of time, you can either, organize your bucket by creating folders and stuff like that. If you are not interested in doing, which you shouldn't be, because that's not what we are after right now, we can essentially just upload any kind of data into that. Okay. So what I'm going to do is I'm going to upload some dummy data. So I'm going to go ahead and look for essentially something on my drive that I can just put here. So give me a moment. So let me just go to AWS. Okay, and then there is this file here. Okay, so I dragged and dropped a file here, which is basically my index.txt file. It just consists of an H1 header from HTML, and that's all there is to it, right? So it will show you this. You can drag and drop, you can use that upload button, and you can browse through the file directory that you want to do. You can upload an image, whatever it is that you want to upload, just find something that is like of small size, and then just, upload it, drag and drop it, or just browse it and then upload it. Okay, so this is basically the URL for your S3 bucket. So what I'm going to do is basically, just for the sake of sanity, I'm just going to copy this and keep it somewhere else. Okay, so I'm just going to keep it here. We don't need this entirety of it. All we need is basically this S3 forward. Okay, and then the name of my bucket basically becomes my URL itself. So S3 test dash data. So all I need is this piece of information. Okay, and it's basically not within the HTTPS domain. It's basically within the S3 domain itself, right? So that is an interesting thing that you have to keep in mind. Okay, so everything is done. You can change the permissions later on if you're working at it. So you can think of it like a Google Drive, right? Another type of Google Drive itself. So you can upload it. It's a pretty small file. The uploading will be done, and then you can basically close this interface, and it will show you what is happening here. And at this point, you are basically done with the first step that is there for our exercise, which is to create a dummy bucket, another service, right? So the next step is to basically create the IAM role that will allow an EC2 instance to kind of access this bucket, right? Because in the absence of that, EC2 instances won't be able to communicate with S3 buckets, right? So the next step that we are going to do, step 2 of this exercise, is that we are going to go into this IAM service back again, because that is where you can create anything that is related to permissions and policies. That is the go-to place for your service, right? So what we are going to do then is, to the left-hand side, the menus, we had work with user groups and user roles, users itself, right? So the next thing that we want to do is just go into roles. We see that there are 2 default roles that are provided to us, but that is not what we are looking for in this particular instance, right? So we are going to go to the top right-hand corner where we have the create role itself. Okay, and then we are going to keep our selection to AWS service, right? Because essentially what we are doing is we are creating a permissions policy for our AWS services to be able to access other services, right? So here, there are many different services which falls in this category where we have to create roles for them so that they can assume those roles and kind of dispense the duties that are associated to that role, right? So some common use cases AWS shows you. So for example, EC2 is there. If you have serverless computing, you are generally going to be using AWS Lambda. So the difference, essentially, just to give you a quick insight between these 2 platforms, is that when you think of EC2, think of a virtual machine itself. So it comes with the entire software stack, gives you the CPU, you decide the CPU, you decide how much RAM do you want, you decide what is going to be the operating system, you decide how much storage you're going to associate with that, those kind of things, right? So that is all about EC2. So if you're running a server there within EC2, or if you're running a process inside of EC2, you decide what the infrastructure is going to be, and then you develop the process within that by installing any kind of additional software stack that you might need to support your application. Whereas when you're working with Lambda, you just work and focus on the processes that you're trying to develop, right? In the form of function calls, okay? So you develop those function calls and it will be triggered by certain events, right? You don't worry about how much CPU power is required to run this, how much RAM power is required to run this, how much memory you should associate with this particular process, so on and so forth. So Amazon takes care of all of those things, right? And you focus on the design of the actual application itself. So anytime your application executes, Amazon will charge you based on whatever your execution time is for that particular process, right? All of the underlying infrastructure is handled by AWS itself. So that is why this particular, functionality is called serverless computing. Doesn't mean that there is no server. It's just from a developer's perspective or from a client's perspective, they can focus on the application and allow AWS to worry about the infrastructure, right? But if you want more control, then you need to go for EC2 essentially. Okay, so what we want to do, and if there are other use cases that does not fall into either EC2 or serverless computing using AWS Lambda, then you can kind of browse through all of these different lists of different set of applications. So you even have RDS here, which is the relational database service and those kind of things. So you can check this and keep in mind that many of the services which are present in AWS are capable of assuming different IAM roles to which permission policies are associated with it. That allows them to communicate with other AWS services without the need of an access key or an API key, right? So that is basically the gist of the matter. So what we want to essentially use is basically EC2 here. So I'm going to just select on EC2 because the exercise that we're doing is allowing EC2 to connect to an S3, right? And then just go to next, okay? So the very next thing is you will see, just as you did for user groups, to associate permissions and policies to this role, okay? This is not a group, it's not a user group. So this is a IAM role that you are creating here. So we know the role that we want has to do with S3 bucket, okay? So we are going to press S3, and then we are going to see what Amazon has to offer with respect to all of these different permissions and policies that are out there. So we can kind of extend this a little bit. You can read the description here, but some of these names are self-explanatory, so we can kind of understand what this is kind of referring to. So here I can see one which kind of makes sense, that I'm giving complete access over Amazon S3. Okay, if any of the services are associated to this role. But what we are going to do is we are going to follow the rule of thumb for minimalistic permissions. Okay, that's where you should always start whenever you're trying to figure out what kind of permissions do I associate to a user group or do I associate to a role. A good rule of thumb is to start with the most minimalistic policy that is required for that particular service or that particular user group to kind of dispense their functionality, right? So here, all I want for the EC2 service to do is not to write on the S3 bucket. We don't want any kind of write access. We just want to give it the minimalistic access, which in the case of storage is read-only access. So if you have just read-only access, you cannot edit anything. And if you cannot edit anything, well, I mean, you cannot say no harm is done. It depends on your use case scenario, but at least it's going somewhere, right? So I'm going to find this, which is the read-only access, and I'm going to check mark this. You can click on this plus sign here, and you can see that what kind of permissions or actions is allowed that is associated or kind of embedded within this policy. If you want to edit this, you can copy it and create your own permissions and policies by using this button here at the top. Right, append to whatever or however you want to change this policy. But for me, at least for this particular demo, I don't want to change anything. I just want to select this, okay, and then go to next. All right, and then we need to give it a role name, what this role name is going to be, and I will just say EC2-access S3. So not just access, let us just say read access S3, okay? And then allow EC2 instances to call AWS service on your behalf. And we can just say, instead of saying AWS services on your behalf, we can just say AWS S3 services and not call it. We can just make it more specific, read AWS S3 services or not services, but we can just say S3 bucket on your behalf. Right, so something like this, you can modify this. check everything else, looking good. We have an S3 read-only access. If you want to add some tags, you can add some tags. And if everything looks good, just hit create role at that certain point of time, okay? And once that is done, you will see a green banner at the very top. And you can also see that we have an EC2 read access S3 that is associated with it, right? So now the next step and the last step for understanding IAM roles is that we have to go back to our EC2 dashboard. So again, search for EC2, go to EC2 itself. By the way, you can do all of this by creating different tabs in your browser if you want to, if you don't want to move back and forth. So that is one option. Go to launch instance, okay, and follow the steps in order to create an EC2 instance. So here I will give the name and I will call it, let's say, EC2-S3-access, okay, in order to kind of elucidate the fact that this is what we are working on. And then we want some AMIs here. So I'm just going to use my Linux AMI. Okay, T2 micro is always where you should be for your free tier account. We already have a key pair login that we have created. I just want to make sure that I actually have it here. And we don't follow that same problem from last time. So let me just find that person here. Okay, so there's demo_ohio_kp. Yep, that is the one. So I have it, no problem, looks good. And after that, make sure that it is associated to the VPC that you want to. We don't have any preference for the subnet, public IP, whatever. We just want to select an existing group. So we are going to select the security group that we have already created in the last class, right? Which is the demo SD Ohio. And it has permissions for SSH, it has permissions for RDP, web access, and all those kind of stuff. We leave the storage volume default. We don't have to give any kind of user data or check any advanced details. So everything looks good. So we're just going to hit launch instance and then wait for it to do all its stuff, right? So we're just going to say view all instance, let it do its stuff, finish its status check. And once that is done, we are going to access this particular terminal, right? So let us wait for it. And I will stop the recording while this finishes launching. And once it comes back on, I will resume the recording again. So let's just wait for it to finish its stuff. All right. So at this point, our EC2 instance hopefully is running. We are still kind of waiting on the platform with respect to getting, okay, so the checks is passed. So we are almost there. So we can select on this and that this will give us all of the different informations that we need with respect to kind of working with this instance states, right? So what we want to do first now is connect to it without giving it the permissions, right? In order to see what exactly happens when we are trying to kind of access it, right? So when you go to connect, we are going to follow the SSH connection policy. So what I'm going to do is just copy this, go back to my git bash terminal, and then just paste it, right? And then it will ask me, do you want to do stuff like this? And this will just allow me to kind of log into my EC2 terminal, okay? Should have just used command prompt, but anyways. All right, so this basically, we are at this point kind of logged in to our EC2 terminal, right? So what we want to do here, we'll just clear this out. And essentially, we want to kind of ping our S3 bucket, okay? So the way we want to ping is we want to use the AWS keyword in order to kind of activate any specific type of AWS service, right? So since we are within the EC2 instance domain as well, the terminal of that EC2 instance already comes with the installation of the AWS CLI, right? So if you remember in the first slides or the slides where we were talking about VPC, towards the very end, there was an installation guideline with respect to the Amazon CLI, right? So please install that if you would want to run AWS-based commands directly from your CLI. So that means what I'm trying to say here is that the S3 bucket is pingable on the internet, right? You don't have to get into AWS platform and then try to connect to S3, right? But if you want to do that, you will have to use this AWS keyword, because what follows after this is the name of the service that you're trying to ping, okay? And then you need to provide the URL of the bucket that you're trying to access. So what I want to do here is basically list the different content of the S3 service, which is recognized by the URL, which is S3, what was it? S3 : / and then the name of my bucket, which is Sen-se test data, right? So here I will be doing S3 : / and then Sen-S3 test data, right? So essentially, when you type this in, right, you will get this particular message that it is unable to locate the credentials. And notice what it is kind of pointing us towards, that what it is trying to say, that this EC2 instance doesn't have the required credentials in order to access this other service that you're telling me to access, right? Which is recognized by this URL, because ls is basically a read operation. If you think about it, if you're familiar with Unix commands, you all know that when you ls something, you basically are shown the contents of whatever directory you are in currently, right? So if you think about it, or if you read between the lines, basically what you're achieving through ls is a read operation, right? So all I'm saying is that, hey, go to S3, I want to access this S3 service, read it, and read the contents, which is basically recognized by this URL. So we don't have the permissions here. So you can go to AWS configure, and then you can set those permissions up or something like that. However, we are set up for a different task, right? And the way we are set up for this particular action is when you select this EC2 instance, you will notice here the connect is there. You can terminate, stop, reboot the instances using this, but there is another third button here, which has certain additional options, okay? And that additional options will be in the form of instance setting. So I'm looking for instance setting here. Instance setting, it was right there. And then I want to find attach roles. Can somebody see attach roles here? Edit or attach roles. Attach to autoscaling group, termination policies, shutdown behavior, change instance type, edit user data. What am I missing? Where is it? Did they change it? We don't want to do attach policies here. Where is it? Resource naming behavior. Okay, did they move it? Okay, so they moved it from instance setting to security. So here we need to modify the IAM role. Okay, so again, did everybody get that? If people are still trying to find it?
Yes.
Yeah, it has been moved to security. It's not in the instance setting anymore. Okay, so here you need to choose an IAM role. And you can see here, this is the IAM role that we had already created, which is the EC2 read access S3 that we have developed. We are going to select that. Okay, did it give us any other option? No. So if you don't have an IAM role created, you cannot basically suggest it because it doesn't know what to do with it, and just click on update IAM role. Okay, so at this point of time, if you want to, you can reboot it in case it doesn't work. We are going to give it a direct try to see if it was able to kind of update its permission policies. And then we are just going to hit the same command that we ran a little while ago. That is, we are telling AWS that from this EC2 instance, please go to S3 service, perform a read operation on the bucket, which is identified by this particular URL. And now we can see that I uploaded this index.txt file. You should be seeing whatever data that you guys uploaded on your end with respect to EC2. Now, here, the most important thing is there were no API keys involved. There were no access keys involved. Okay, the only time we did use an access key was to basically terminal into our EC2 instances itself, right? Other than that, there was no, like, nothing to do with saving a key on our local system and then providing that key in order to access it and so on and so forth, right? So this is an easy mechanism where you can kind of directly access. And what happens is that instead, if your program is being hosted within the server that is running on this EC2 instance, then you can see that you do not have any kind of API key that is involved in order to access that. As long as you have the correct IAM role, you can put that function call to your program, and then your program, AWS can basically, EC2 can basically get the data for you from either a database, from either an S3 bucket, and bring it to your program itself, right? There is no involvement of any secret key. And that is the reason why this method is a little bit more secure compared to working with a security key or basically with an access key, right? So keep this lesson in mind because this is something that is very useful if you want to do things in a more secure fashion than just simply using API keys and stuff like that. And remember, this is not just for EC2 itself. There are other services which can assume IAM roles as well. So just keep an eye out in the back of your mind, or just keep a note in the back of your mind that, hey, I can take this route rather than always kind of by defaulting to an API key or an access key. Okay. So everything is done here. We can just stop this particular instance. So I'm not going to close this. We'll probably need this again. So again, once we're done with any exercise, please destroy all the resources or purge all the resources that we are working with. So here, I'm just going to stop this instance. Not stop it. I'm going to terminate this instance. It will tell me the same story all the time, and it's shutting down. And again, a piece of advice and a note, you might see it is shutting down, but actually ensure that it is terminated before you close this window whenever you are done, right? The other thing that is running is basically your S3 bucket. S3 basically is charged based on how many gigabytes of data are you storing. That is basically the cost model for your S3. I have a text file, which is very less. And also for 12 months, I have almost 30 gigabytes of access on S3. So I'm going to keep it open for the time being because there is a self-exercise later on, which I need to explain it to you all, for which you will need an S3 bucket, and you need those two particular files that I was talking about. You will essentially need that. So what we are going to do is we are going to kind of integrate the lessons learned in this particular exercise with that self-exercise that you're going to be doing to kind of achieve a little bit more, I wouldn't say comparatively more complex than what we just did, right? So that is where we can be. Okay. So the next thing that we want to talk about, the next exercise that we want to do today is to learn about elasticity. Okay. So when it comes to infrastructure, of course, knowing how to work with a VM, knowing how to give the VM permissions to access other services, that is an important thing to know. That is very true. But there are two important things in addition to all of those is what we call as elasticity, which here it is referred to as auto scaling, if you pay your attention to the left corner of my screen. And then we have load balancing, okay, which is to basically kind of distribute the incoming traffic such that the underlying servers that you have, no one particular server gets overloaded because of your network traffic, right? So these are the two things that makes cloud really cloud, right? Because if you have to manage all of these things, what's the point? Then all you're getting is that, oh, you don't have to buy your actual resources. AWS is giving that, but then you have to always monitor what's going on, right? So, of course, utility service computing, okay, provides you with these two different features, where auto scaling essentially is what we also know as elasticity. And the whole idea is that AWS has platform as a service features that will do the monitoring for you of the infrastructure that you rent out from Amazon, right? And then based on certain policies that you specify or whatever certain basic things that you specify, it will keep on monitoring what is going on. And whenever an event is triggered, it will take the actions that you have specified with respect to your particular deployment of your VPC, right? All of the different stuff that you have. So always, again, make sure that it goes to terminated, okay? And not shutting down and stuff like that. That's another thing. So the next thing that we will move to is auto scaling groups, okay? So auto scaling groups, there are three major factors that are involved when it comes to elasticity. But what you have to specify to AWS. And then around that, there are a lot of other extra features that are kind of floating around, and you can tie it on as an add-on to make it more robust and things like that. But at the very bare bone, elasticity is defined by 3 features. Okay, the bare bone doesn't mean that that is the complete or the comprehensive description of how elasticity is managed. Please keep that in mind. Of course, there are additional features. Okay, so the 3 things that you need is you basically have to tell the ASG, auto scaling group. Okay, you basically have to tell it, you have to create a template, and you have to tell it that what is the minimum size of your cluster. And the reason why I call it cluster, because it is with the assumption that when you are scaling up and down, you will have more than one, well, typically more than one machine, right? And you can group that into a cluster, right? So what is going to be the minimum size of your cluster? Okay, what is the desired size of your cluster? And then what is the maximum size of your cluster? Okay, you get to choose that you can specify that. Otherwise, you can specify it on other policies, which is not depending on min, max, and desired capacity. We will talk about that right after this exercise, which is the target tracking policy. Okay, but here at the very bare bone essence, all you have to do is specify these 3 factors. So what AWS will do is that it will keep on monitoring using its platform as a service that is known as CloudWatch, which is the monitoring service at AWS. It will keep a track of what is going on with your cluster, okay, or auto scaling group, so to speak. If more capacity is needed, it will add it, going up till the maximum size. If it sees that you're not using the extra computing resources that has been given to you, it will remove them. So you will scale down, right? If you do not have the desired capacity, or if something happens to the desired capacity, then it will try to maintain the minimum. If you go below the minimum, it will increase it back to the desired capacity, right? So it is kind of like balancing act of a weighing scale, where you specify that, hey, I want to be this much minimum, this much maximum, but this is my desired. So you just try to be in that window, right? And that kind of gives you that happiness that is what is happening, okay? So the way it works from an architectural perspective is that, let's say you have these 2 different availability zones, right? So if you have 2 different availability zones, you can have subnets that are spanning across all of these availability zones, or you can have individual subnets within these availability zones, right? So, and then let's say you have different EC2 instances within that, where you specify that, okay, this is the minimum, this is the maximum, and this is the desired capacity that I have, okay? Then what happens is that these EC2 instances, or this grouping, okay, because this is grouped together into what we call as the auto scaling group here, right? That is the ASG, which is, I'm referring to it as a cluster, okay? But it's technically not a cluster as such, it is an auto scaling group. So when you define or declare the ASG, all of these different EC2 instances that could be present across different subnets, across different availability zones, they get grouped into a single cluster, so to speak, right? For the lack of a better word, all right? What happens is then that group communicates to AWS CloudWatch. Remember, AWS CloudWatch is essentially the monitoring service, okay? So when we created our custom billing alarm, we had to keep a track of the services that we're running within our ecosystem from a global perspective, right? So as the root user, which is the owner, we created an AWS CloudWatch billing alarm, like our own custom billing alarm, which is monitoring how much dollar amount is going to be charged based on the services that is running, okay? So here, once AWS CloudWatch, it keeps a track of the health or the conditions of the different EC2 instances. Now, when we talk about health, it could be to get a heartbeat signal. If you're aware from fundamental networking, heartbeat is the process where any monitoring service sends a ping to whatever it is monitoring. And as long as it gets a response back, that it knows that it is running, right? So that is basically a heartbeat signal in its simplest form. So it could be a heartbeat signal to monitor the health of the different services. It could be tracking a particular target, right? Based on certain metrics. So for example, it could be also tracking the CPU usage of all of these different instances that are clustered together. And what it does then, it reports back to this auto scaling group, which is basically in the form of a service that is kind of providing this overwatch or oversight of the entirety or managing the entirety of the auto-scaling group, right? So there is a service or a process that is running on top of this entire group, which is responsible for the administrative operations within this group. And the administrative operation within this group, specifically speaking, is with respect to elasticity, that whether it needs to make the decision of launching a new instance, or whether it needs to make a decision to remove an existing instance because it is not being used. Okay, so what we are going to do in the first exercise is basically understand how to create our own ASG, okay, using that min, max, and desired value. And then in the next exercise, if we still have some time, we will talk about how to do the same auto-scaling group, but instead of just doing the health of EC2 instance, that is whether it is alive or dead, we will monitor the CPU usage and kind of work around that, right? So the first thing, again, please follow your instructions on the PowerPoint if you would like to do so. Otherwise, you can follow with me. So the first thing that you want to do, come to this left-hand menu, scroll down to auto scaling, find auto scaling group. Please remember, you can go to launch configurations where you can specify what type of launch configurations that auto scaling group needs to follow. Okay. However, this is going to be taken off of support. So they're slowly phasing out the launch configuration option. This is basically being translated into launch template now. So you don't have to worry about this for new users. For old users, please keep that in mind if you have ever worked with this before. So everything that you need is kind of consolidated here in the auto scaling group option itself. So for a first time, you go to create auto scaling group and we open this dashboard. On the left hand side, you can see the different steps that is there. Quite ironically, the first two steps are the important steps, and after that, everything else is optional. So if you want to leave everything, you can leave it, get to step 7, just review everything and set it up, right? So we need to give it a unique name here. So what we are going to do here is I'm going to give a unique name. So I will say demo ASG exercise 1, something like this, right? And you guys can give whatever name that you would want to give. The next thing that we need, which is the alternative to our launch configuration, is basically the launch template. Okay, so we don't want to create a pre-launch configuration. We want to create a launch template. So essentially, we need a launch template at this point of time. Now you can notice here that we don't have any kind of launch template. That is, this auto scaling group doesn't have any reference on how it needs to start. So just click on this create launch template. So I'm going to do a middle click of my mouse button. So set it, this opens in a new window. It will open in a new window because I can see this thing kind of pointing outside as well. But, you know, I kind of follow this practice just to avoid that headache that just in case that they did not code it in such a way that it opens it in a new window, I will have to do a back option and I will lose my work and stuff like that. Anyways, coming to the launch template, the prompts are kind of self-explanatory, kind of like this being here. Okay, so I kind of like this. So you have to give it a name. So I will just say demo launch dash template for ASG exercise 1. Okay. Launch template ASG exercise 1 demo, something like this, right? And you can give it a description here. So maybe I can give it the same description is demo for elasticity or auto scaling in AWS. Okay. So you can either choose to kind of allow AWS to give you guidance with respect to auto scaling. So you can kind of check this button or uncheck this button depending on what you want to do and what you don't want to do. But I can just walk you through the basic steps that you need in order to create your own launch template. And that involves, or the steps are pretty similar to creating a single EC2 instance. So remember what this launch template is doing is it is just telling you that, oh, this ASG process is going to create all these different instances for me. What kind of configuration do you want for each of these instances, right? It's a cluster of EC2 instances, right? Homogeneous cluster of EC2 instances, by the way. So all the steps that you have or that you have already followed to launch a single EC2 instance, you will basically summarize those steps again within the launch template and then take that launch template and give it to the ASG. And then ASG will follow that launch template and then create all of these instances based on whatever number of instances that you have specified for it to begin with, right? So keeping that in mind, all the steps that you're going to see here is something that you're already familiar with, that we have already worked with, right? So the first thing is we need a machine image. So I will go to browse AMIs. I will select my Linux image. Okay. All right. So Linux image is done. And then the next thing that I want is basically my instance type. So the instance type, I will use T2 micro. Okay, because this is the one that we are working with respect to free tier. So I'm just going to stick to that. I'm not going to choose anything other than that. If you're in a production environment, then you can choose whatever launch template or whatever kind of instance type do you want, or you can go to the advanced setting and check out what other options that is given. We need a key pair because in case we want to terminal into any of the existing EC2 instances that will be launched by this ASG, we need that. So I'm going to choose the one that I already have created, which is my demo Ohio key pair. Okay. We need a security group as well, because remember, anytime you're launching an EC2 instance, it will be associated to some security group. Otherwise, AWS will create something for you, and then you can choose what type of security group do you want. So I want to use the existing security group that I already have, because more or less I have created all of the basic permissions that I'm working with right now, which is SSH, RDP, HTTP, HTTPS. So later on, when I work with relational database, I will edit this security group and add MySQL access to it and things like that, or any database that I'm working with, right? You can go to advanced network configuration. If you want to add an interface card, you can add it. We don't need anything right there. EBS volumes that we need is basically a single volume, 8 gigabytes, general purpose SSD, pretty good. This will be attached to each and every EC2 instance that will be associated. Resource tags, you can add the tags that you want. Go to advanced details. It's going to be exactly the same as launching a single EC2 instances. So that means if you want to add any kind of software stack of your own, you can add a bash script here if you're working with Linux, or depending on the machine image that you're working with, your scripting might change, right? If everything is done, you can leave the rest of the fields as is default. You don't have to worry about that at this point of time. And then all you need to do is just hit on launch template, right? So this gives you a summary here. This widget did not used to be present previously. Kind of makes your life easier, not having to go through everything. But anyways, yes.
Professor, in the PowerPoint, it says to choose the VPC under network.
I think they have removed that from the interface. So
okay.
You can see somewhere the VPC should still be there. Where is my network? Here is the network settings. Oh, the subnet. It only gives us the option for subnets right now.
Okay.
So we don't need to include this, because when we will launch it through the ASG, we can choose which subnets to include for our instances. So we can specify it from there.
Okay, thanks.
Okay, but that's a good point. So what has been pointed out is that if you notice this diagram that we have on the architecture for the slide, you can see that there is one availability zone here, which is basically a subnet for us in the default VPC. And then there's another subnet here for the default VPC. So you can see here in this architecture diagram, the ASG group kind of spans across multiple subnets. And then the instances, AWS will decide, or not AWS, but ASG process will decide where the instances go. And it will always, to a certain degree, try to optimize everything and balance everything out. Okay, so in such an instance here, I think previously the interface allowed us to click on the VPC, and within the VPC, you have the selection of all the subnets, right? So here, instead of doing the VPC right now, what they're offering us is to basically select the subnets. So if you're creating the launch template, which is basically the configuration the ASG process will follow in order to create all these different EC2 instances, you can choose to specify if you want to explicitly launch all of the EC2 instances in a given subnet, or a combination of all the subnets that is there, right? The availability region is dictated by this top right-hand corner thing, right? You don't have the power to go across availability regions. You have to switch and then redo, okay? So that is something that you cannot do from a particular availability region. You cannot touch another availability region. That's something that so here, I'm just excluding it from the launch template, because I'm not telling the launch template where I want to do it. I believe later on, I should have the capacity to specify which subnets to include. If you do not want to do that, all you need to do is basically click on this, and you can see the VPC is specified with the subnet itself, because I believe I understand why they did the change here, because the subnet is what dictates the actual launching of the instances, and a subnet is already the subnet already belongs to a particular VPC, right? So if you select the subnet, you're already kind of fixating on the VPC itself and not the other way around, because you don't deploy something to a VPC, you deploy something to a subnet, right? So if you want to select the subnets, then you click on the subnet, and then that will make it exclusive to that particular subnet, right? So if you want to change that, you can change it here. But if you do not want the subnet information to be present in your configuration file, then you can essentially just ignore all of that and then kind of move forward with this operation, right? So let us just check everything. Linux, T2 Micro, security firewall, storage, all good. Name is demo launch template ASG. Okay, so, and just create launch template after that. Okay, so once this is done, we will go back to the auto scaling group. So the first tab, we were in the process here. So we'll just refresh this just to make sure that our template is there. And we can see here, now we have the demo launch template. Okay, so this is the option that you have. And then you can move on to the next step in your slides, which is slide 9. And you can follow through with the steps that you have there, right? So once you select the launch template, it will show you the default versions that you have. So we just have a single version of this launch template. We have not done any kind of editing to the launch template with the same name, right? So you don't get all of these different versions. It will just show you all of the different information again. Okay, so move on to next. All right, so here is where they moved it. So essentially, you get to choose your VPC. And you get to choose the subnets that you want to kind of launch all of these different EC2 instances that will be thrown at you. So what you want to do is, or what I want to do is, I want to select all of these 3 subnets. So I'm just going to select all of them and leave it as such. So what I'm telling is kind of distribute the launch across all the available subnets that you have within this particular VPC. And the VPC is for the entire region itself, and you can have multiple VPCs. Please keep that in mind. Always remember, doesn't mean that you will have only one VPC within a given availability region. You can create as many VPCs as you want within an availability region. Please make a note of this, and please remember this. Since we are working just to understand the functionalities of different stuff, I'm not creating multiple VPCs and complicating stuff, right? But for an actual production environment, a practical environment, you do have the capability to create multiple VPCs, okay? Just keep that in mind. It's just another service. So there's no restriction, oh, I can create only one EC2 instance. Just like that, there's no restriction on VPC. All right, so selected my VPC, the default VPC, selected all of my default public subnets, okay? We don't want to override the launch template itself, right? We want to stick to this, okay? So everything looks good here. Just check it, make sure everything is working. So if you override the launch template, basically you have the permissions, or not the permissions, you have the capability to kind of change everything that we just did in the launch template, which is kind of funny, because if you had to do that, then why did you create it in the first place? But anyways, go to the next step. Okay, so the next step gives you an additional option of creating load balances, or putting a load balances in front of your VPC. So if you notice this architecture here, going back to the architecture one more time, if you notice, this is the ASG process. This is the oversight that is there for this entire group. What you can do in addition to this, if you have a front-facing application, let's say for example, a web server, or if you have a back-facing application as well, which is for networking purposes and stuff like that, then what you can do is that in front of the ASG, you can put a ELB. ELB stands for Elastic Load Balances. So what happens is that instead of pinging from the outside world, these individual instances, you ping the DNS of the ELB, and the ELB decides that where the traffic needs to be rerouted, right? So that is an ELB exercise. We will do that right after the target tracking policies of the CPU and stuff like that, right? So we don't have to worry about that per se at this point of time, okay? So we will just select no load balances. Or if you already have created load balancers, you can create that, or you can create a new load balancers, whatever it is that you want to do. Health check, you don't have a load balancers right now. So you don't have the capability for the load balancers to monitor through CloudWatch as to what is happening with your instances. So we will just leave it with the default options. We don't want to change it since we don't have an EOB. It is something that we don't want to do. Okay. And then you can enable the group metrics collection within CloudWatch itself, or you can leave it as is. I'm just going to leave it as is. We don't want additional information from CloudWatch. We don't need that. Okay. And then next, I'm going to go to the next option. And this is where we have the three different fields that kind of dictates what I want to do. Okay. So I will give it something simple. Whoa, not this much. Okay. So I'll just choose 2 and 3 for my desired capacity. And then for my maximum capacity, I will just go to 4, something like this, right? Very simple, just to show you how it essentially works. In addition to this, so this policy is only going to track the health of the instances. So that means if an instance is not reachable, then it's going to take action. That is the event that is going to trigger. However, if you do a target tracking scaling policy, and what the target tracking means is that you have a metric that you're tracking, and based on that event, it will scale up and down. So for example, let's say a CPU usage, that is a target tracking, right? Because your target is basically the CPU usage, and you're tracking that. And based on whatever threshold that you have defined, it's going to scale up or scale down, right? Here, we are not doing the target tracking, right? We are just concerned about the health of the EC2 instances, just to understand how ASGs work. So we're just going to keep the scaling policies as none, okay? And we are going to rely on the group size as the auto scaling policies for the time, okay? There is a scaling protection that we have, okay? You don't want to select this at this point of time. We don't have any need of this. So we're just going to go next. You will be notified by SNS. So just like you will be notified by SNS for custom billing services, if you want to create a new simple notification service, such that if your instance goes down, ASG will notify you through SNS that, hey, you just lost an instance. Or if a new instance was created in order to maintain something, then it will tell you that, hey, we launched 2 instances here because this is what is happening, right? So if you want to get that update from time to time, which is something good to have when you are actually an IT manager or an administrator on the cloud, right? Then you always want to create this add notification. So for now, I'll just skip it, but you all know how to create custom topics in SNS. We did that in the custom billing assignment. Okay, so I'll just go next and give tags if you want to. I'll go next. It will tell you to review everything. And I will just take a leap of faith. Okay, and I will just hit create auto scaling group. Now, create auto scaling group, then you can select this particular thing and you can go to this top. You can see that there are many different tabs that are going on. So if you want to monitor what is happening from information from AWS CloudWatch, then it will show you all of these different services. Okay, and then please remember that in the free account, this gets refreshed every 5 minutes or so. I'm not sure of the exact value, but if you do the paid service for CloudWatch, it will give you the refresh rate, or the frequency of the data that will come to you will be every 1 minute, right? If you pay for it, right? So here you will have 2 CloudWatch monitoring details. You can either monitor the ASG as a whole, the cluster itself. So it will show you the entire cluster, or it will show you the different EC2 instances that is going to be running as monitored by the ASG cluster itself, right? That is one option. If you want to check at the logs, then you can go to this tab for activity, right? And this will show you here that user request is created. And then it changed the desired, initially there were no EC2 instances. Now it is moving on to 3, which is what my desired capacity is. So it will launch 3 EC2 instances. And then it is launching all of these 3 different EC2 instances, right? So these are the 3 EC2 instances. Everything was successful. So you can monitor if something goes wrong. You basically go to activity for your auto scaling group that you created, and you can check it. So what I'm going to do now is I'm going to kind of middle click this AWS home button because I need another tab here. And then I'm going to go to EC2. Okay, So in EC2, now you can see the dashboard, starts to look a little bit different. One auto-scaling group, two security groups, one we created, one that was by default present, 3 volumes, because we have 3 instances that are running. Okay, so 3 volumes have been associated to those instances. So if you go to this instances operation, you can see here we have this one terminated instance from previous exercise, but now you can see that we have 2 more instances. It is in the initialization process. It will go through the status check. So what is important for you to understand is, first and foremost, if you want to think of a takeaway, of course, ASG is for your auto scaling, right? That is what the service is about. And it is a subservice within EC2 itself. That is basically what you have to remember. Okay. The second thing that you have to remember is that you can target track ASG groups. So what I mean by that is that you can track things like your CPU load and those kind of behaviors, or you can just check the health of the instances. That means whether it is running, whether it has crashed, something has happened, and some action needs to be taken because of that particular event, right? However, there is another thing that you have to remember, that ASG is basically a way to launch, launch multiple instances in one go. Okay, you will see there are more and more integrate ways in which we can launch a group of our instances, but ASG is basically the forefront, not the forefront, but basically one of the very first services that we are learning about that enables us to launch multiple instances in a single go with the help of our, so how do we do it? Basically by using the configuration template. Okay, by creating the ASG template, we can specify. But remember, the only downside is all of these instances are going to be homogeneous in nature, because if you're following the template, then you can do it. So how do you overcome that challenge that you face? Well, you can override the template configuration. That is why you have it there. You can override it, or you can create a different ASG for a different set of instances that probably is running a different set of specs on it for that particular purpose. Okay, so let this run and let us move on to the next exercise, which is to basically do the same thing, the ASG thing. So now if you want to kind of actually demo this, so what I can do is I can take 2 instances, okay, and you guys can try it out in order to kind of check it out as well. And you can see that since it is running within the ASG environment, then it is also kind of getting the monitoring feedback from CloudWatch as well, right? This is something that is kind of in addition to the initial EC2 instance, because if you launch a single EC2 instance, you don't get monitoring unless you connect to it, right? You connect CloudWatch to it and say that, hey, CloudWatch, please go and do this and that, right? But since it is from within ASG and ASG is kind of supplemented with CloudWatch, you have the option. So what I wanted to show is that what you guys can do at this point of time, I believe it has passed the checks. Yeah. So you can take 2 instances, and you can see here by default, if you select the subnets, it's going to kind of balance out the distribution of the instances. So you don't have to fear the fact that, hey, I selected 2 subnets and I have 6 instances that I want to launch. That is my desired capacity. What happens if one subnet gets 5 and the other one gets 1? It's not going to happen, right? ASG will try its very best to balance everything out. That is basically the whole idea. So, all right, without digressing any further, what I want you all to try out is just select any 2 instances. And what you can do is go to instance state and then just hit terminate instance. Okay. And just go and terminate it. Let it terminate. Go back to your auto scaling group. Okay. Things are specified here, and give it some time and keep checking the activity. Eventually, you should see here within 5 to 10 minutes that it will detect that there is no heartbeat from 2 of the instances that was launched. Okay. And since our capacity has fallen below the minimum capacity, it will first take it to minimum, and then it will take it to the desired capacity. So that means it will relaunch those 2 instances in order to kind of meet the requirements that we have specified. Okay, so you can try this out. That will essentially show you how this ASG actually works, or how it actually performs its operation. Okay, the very next step that we need to do, let it do its stuff, and let us talk about the next operation. Okay, so it has terminated here, and let us see that if it has detected anything here. So I'm just going to refresh this whole page. Go to activity. Okay, so CloudWatch still has not detected it. So hopefully it will get back to this. So we will check it out later on. And let us talk about the next steps, or the next exercise that we want to essentially do, right? So the next step is to kind of append or supplement this ASG with target tracking. Because right now, as we can see, the only way, or the only thing that we're monitoring is whether these instances are alive or not, right? This is going to take a while. So, but that is not the most practical way in order to kind of perform those operations, right? Because essentially, of course, failure can take place, and you might want to, replace those failed instances, right? However, sometimes you also want to keep on the scaling policies with the live instances based on certain parameters or certain metrics. So the exercise that we are interested in, that we want to kind of perform, is the idea of tracking the CPU usage. Okay, so for that, what we need is our 3 instances that we have created, because we can track. Okay, here we go. So right now we can see here that we have 2 new instances, or a single instance has been initiated. So that is the minimum instance that we have here. So let us go to activity. So this has noticed. So it is, previously this was here. So now it has created 2 more instances. So that is up and running here. I just wish they allowed us to kind of bring this up a little bit. Anyways. Okay. So this is initializing, and there should be one more that should be initializing. So running, and then terminated. So I'm still waiting EC2 to kind of with. Okay. So let's talk about this a little bit, and let me give you the directives of how this works out. So essentially, what we are going to do is, we already have the ASG that we have created here, right? So all of this are already there. In addition to the ASG, what we now need to set up is a target tracking policy for CPU usage. That is what we want to work, right? So what we need to do now is, we need to revisit back our ASG, which we have already created. So this is the ASG that we have created. So let me go back. Yeah. So if you go to auto scaling groups at this point of time, this is what you should see on your screen, right? So just go into that ASG. Okay. So that is what you need in order to work with that. And then you need to find out automatic scaling from the top menu or tabs that is there. We saw the details here, we saw the activities, we saw the monitoring, right? But there is also automatic scaling, and there is instance management. So if you want to do individual management of all of the different EC2 instances, you can, instead of having to go through it through this instance here, that is to go through the EC2 dashboard page, you can just visit those operations or see what is happening here itself. And then the same actions that you had, you can basically kind of opt into it, but you will get those actions with respect to ASG only. Just keep that in mind. That's the only way. But what we are interested in is, we want to go to automatic scaling. Okay, because right now it will launch it, but it will never go above the desired capacity. If you guys notice what I'm trying to say here, if you notice, the details specifies minimum is 2, max is 4, desired is 3. If a system crashes, that is always going to go down. So that means ASG will create new instances to make up for whatever crashes has taken place. But what about going up? That means if 3 instances are running, how do I ever go up to 4? Right? Because ASG will not do it. There is no reason for ASG to do it unless it sees that it is not able to support the workload. And that is where our basically our segue lies. It's like when we say that, oh, it is not able to support our workload, that means we have to kind of define our workload based on certain metric. Okay, I hope that makes sense of what I'm trying to say. So we need to track something here, and that is done through automatic scaling tab within ASG. So you need to have an existing auto scaling group that is already there, or when you're creating it, you need to create that. And then you need to click on this button, which is to create a dynamic scaling policy. If you already have a dynamic scaling policy, you will see something here in this particular subfield here. So you can create it from here if you don't see this button here. So it's the same option is kind of available at this point of time as well. Okay, so click on create dynamic policy, and that will take you to the page of target tracking policy. Okay, so what we want to track is not step scaling or simple scaling, but scaling based on monitoring a certain behavior within our EC2 instance. That behavior is known as target track. That the target is the behavior, right? So we need to specify what that behavior is that we're trying to do, right? So we need to give it a name. So I'm just going to follow my naming convention here. I'm going to say demo target dash tracking that policy. Okay, and then I need to specify what am I trying to track here. So you get many different options here. If you notice, we have average CPU utilization, we have the network usage in terms of bytes, we have the network output, there is the in and out of the network, depending on how much input output is happening in the network. And then we can essentially use the load balancers to be the target tracker for us itself, right? So the load balancer can tell us that, hey, we are hitting the max capacity, please increase, or we have a lot of resources that are sitting idle, please decrease, right? So we can use application load balancers to work. What we can do is basically we can choose CPU utilization, right? And then we can say, what is the target value? Target value is the value that we would like it to be maintained at. Okay, so 50% is basically what we're saying, that is the desired CPU utilization that we will have for all of the EC2 instances that is monitored by the auto scaling group. So in our case, right now, there's just 3, right? And you can have some instances needed with respect to how many seconds of warm-up is required before you start including the metric, or you can just leave this empty. We don't have to worry about this. This just gives you this head start for the instances before it actually starts to monitor. If you do not give any value, then the monitoring begins right away as the instances are being launched. Yes, sir.
Is the target value per instance, or is that total?
Throughout. All. So this is applicable to the auto scaling group. So when it is applicable to the auto scaling group, that means all the instances that are managed by the auto scaling group.
Okay, each would be 50% target.
Each, yes.
Okay. Oh yeah, right.
Yes.
Okay.
Right. So remember, all discussion within auto scaling group applies to all of the instances that is managed by ASG, right? So that means if we go back to the slide to our architecture page, which is somewhere here. So if we have the 6 instance and we say that the CPU utilization should be 50%, that is 50% for each of the EC2 instances that will be present, okay? And not as a whole, because it is managing individually. So the mapping is more or less 1:1 from the oversight process, right? So that is something that you have to remember, okay? So the next thing that we want to do is basically kind of create the dynamic policy and finish up the setup of the dynamic policy. So I can give a value of 50 if you want to change this. And if you want to see the results quicker, then you can reduce the target value to, let's say, 20%. That will result in the event to be triggered faster comparatively in order to see if it is working or not. So you can choose to do that, but you can play around with this value. That is not a problem, okay? So we're just going to create this, all right? And make sure that everything looks good. So we have enabled auto scaling policies. We don't need predictive scaling policies, but if you want to have Amazon to kind of change all of these things for you, or kind of make a prediction with respect to the usage patterns of the organization that you're working with, then essentially you can allow that to happen through creating a predictive scaling policies. You can specify what is happening. So this is good because this provides you a foresight into what is going to happen. So if you have different instances of let's say, what is the behavior of users when dealing with your organization's platform over certain holidays. If that is the situation, then you can teach it. You can teach Amazon what is happening, and then Amazon will be able to predict what is going to happen, right? Otherwise, if you see that the popularity of your products has increased or something along those lines, and you cannot basically, what do you call, in a very affirmative way, you cannot guess what your minimum bound is going to be or what your CPU usage is going to be like, then that is essentially something that you can allow or basically give Amazon to handle, right, using predictive scaling policies, right? And if there is certain scheduled action that you have to maintain, so that, again, coming back to that same holiday example, you know for sure, based on past operations, that the load of users that wants to basically ping your servers increases considerably when a certain period of time comes in the year, right? If you know that, if you have prior knowledge of that, then what you can do is you can create a scheduled action. And in that scheduled action, you can basically change the minimum and maximum capacities that you have created here. Okay, so here we had given this 3-to-1 capacity, right? So if you want to change that, but have it not universally be applicable, then what you can do is you can go to scheduled actions, and then you can essentially create those scheduled actions here. So you have two more options in addition to you specifying the target tracking policies. Is basically you can choose to allow Amazon to predict what is happening, okay? Or you can choose to schedule a different action where you can set a different bound on your min, max, and desired capacity. And you can say how much time you want to repeat it, when do you want to start it, when do you want to end it. So I can say that, oh, Black Friday is around 27th to 30th. So please start it around that time, increase my desired capacity to 10, my min to 7, my max to 20, and those kind of things, right? And that will give and allow Amazon to kind of, check all of these instances. All right. So once that is done, once that target tracking policy is done, what you need to do is basically simulate some CPU load on our EC2 instances, right? So if you go here, you can see that we had 2 EC2 instances that are running at this point because it has brought it down to minimum. Can somebody tell me why we lost one instance? If you remember, we had 3 instances here before we went to our target tracking policy. But at this point of time, we just see 2 instances, and 1 instance has been killed, and it is following the minimum capacity policy. Can somebody tell me, think about it, and tell me why this is happening? It's a pretty straightforward explanation if you connect the dots. Anyone?
Well, if you look at the activities, it's alarm triggered policy, changing the desired capacity from 3 to 2.
Yes, but what triggered that?
Yeah, what triggered it? Yeah, okay.
You're right, of course.
Yeah,
that is the only reason why it will do
from
so.
3 to 2.
But why did it happen? So the detail says we had 3, it started 3. Then we went to automatic scaling. We added this target tracking policy, which is now associated to this auto scaling group. And the moment we created this target tracking policy, and as we were discussing other options that we have, we go back to the instances and we see that instead of the desired 3, we now see 2, which is the minimum.
Is that because you weren't at the threshold, like there's not enough usage, so
Correct.
I got rid of it and went to the
Exactly.
minimum?
Exactly, right? So think about it this way. When there was no target tracking, all that we had are instances to specify. So we said that the min was 2, the desired is 3, and the max is 4. We said that, right? But when we said, and this is just the health of the instances, okay? But when we said that, hey, now we have a dynamic target tracking policy, and the target that we're tracking is basically the CPU threshold utilization, which we are saying that keep the CPU usage around 50%. So that means if for all the instances that are running, if the CPU utilization goes over 50%, then it will create a new instance to kind of relieve that load. But if it says that the CPU utilization is basically, I wouldn't say 0, but let's say 5% just to take some random number, then one of the instances are basically useless. It is much less than 50%. So what it wants to do is just allow or reduce that instance. So if we had 1 as our minimum bound, we would have seen that 2 instances would have been terminated or killed, right? So since our minimum is 2, it cannot go below that policy, right? So this is the way, this is the dynamic aspect of the scaling that it is kind of following and making sure that this is happening and not happening and stuff like that, right? So it cannot go above the bounds, remember, but it will always keep your usage to the most optimal place as much as possible. Okay, so the desired kind of vanishes here. So when you add the dynamic target tracking policies, please keep in mind the desired is, yes, it is desired, but that is not how the dynamic policy will kind of control everything. Yes. Any questions or comments?
Yeah, and it also says in the tracking policy, at least summary, it says add or remove capacity units as required. So that's pretty much following it.
Yeah.
So yeah.
Yeah.
Okay.
So the good thing is we didn't have to kill any instance in order to check whether it works or not. Okay. So here you can check. So the only thing that you do have to check, and I will leave that as a self-exercise, is to simulate CPU usage behavior, because we saw that it goes down, it works, and it also works going up as well. I can tell you that much, but for you guys to see it with your own eyes, I want you to follow the steps that is given in slide 15, where you have to install a dummy app on your instances. Okay, so for now you have 2 instances that are running. So I will walk you through the steps that you have to follow in order to be able to achieve this exercise by yourself, but this will also give you confidence in being able to do it. So what you do is you go to your instances, okay, refresh this, okay, and then I want to find the instances which are running. So do I have any kind of filters here? I remember I added it here. So if I do this, right. So if you just click on the plus sign, besides all of the instances that are present in that list that you're working with, it will add a filter to kind of filter out all of the instances that are only about the running state. So what you need to do next is you need to click them individually, okay? And then go to the connect option, go to SSH, copy your command, open individual terminals for each instance, okay? Because we need separate connection to all of them, right? So that means I already have one command that is open here, so I can either choose to connect to that, but I also need to create another terminal, and I need to do the same process, that is connecting to the other EC2 instance that is running here as well. So once you do those 2 connections, that means you have a terminal connection that is established with these 2 instances. Now, what you want to do is you want to now in the terminal follow these 3 steps. Okay, so there are 3 Linux commands that I have already included for you. We need to install an application. So for that, first we need to add the repositories. So this is the repository that we will use. Then we will install the actual application. The name of the application is the stress utility application. It's a dummy application. So you're just going to install that. And then we're just going to kind of run the stress application using the stress command and then give it a value of 8, which kind of is the number of threads that will be opened and then run on the application. That will put some load on the application. Okay. Run it.
We're at 7:15, just FYI.
Okay. So we will just run this, okay, and then give it some time, and then go back and check ASG again. Okay. Once the load goes above, so this option will take your load to around 70%. So once that happens, you will see that ASG through the target tracking will create a new policy, not a new policy, basically a new instance. And then that will kind of give you the demo of how target tracking policy works, both scaling up and scaling down. Scaling down, we saw by default it happened because nothing was running, but please try this out. So please try this out as a self-exercise. And then once you're done, and don't forget to try it out. Don't just, take my word for it. Please try it out. You will understand how things work, okay? But once you're done, delete your ASG. If you delete your ASG, that will shut down your instances, but make sure you double check that from EC2 dashboard again, okay? ASG controls all those instances. So if you terminate your ASG, you will terminate the instances that are associated with it. So in the next class, we will talk about load balancing, and we will do the demo of load balancing and then move on to our discussion with storage services, which is the elastic block storage, the elastic file storage, and then the simple storage service. So we will talk a little bit about these and how they work and what are the different features that is associated with them. So as my last step, I'm going to terminate on my end, but please, you guys try it out. Don't delete it unless you try it out, okay? And then please remember to delete it, okay? So I'm just going to go to auto scaling group, go back, and then essentially delete this auto scaling group that I have created and terminated. So you're just going to click this and just hit delete here. So that is the way you delete it, okay? So with this, I will wrap up today's class, and then I will see you all on Monday. Okay, and if the weather is good in person, if not, I will let you know. All right, thank you.